quantum computers actually building the molecules for life-saving drugs. I always thought that was, like, way off in the future. But this news has me wondering if we're closer than we think.
Yeah, it really feels like this field is just taking off faster than anyone expected.
Yeah, and this week it's all about this company, Qunova Computing, right? They're claiming a major breakthrough with their new quantum algorithm, one that can supposedly make these chemistry calculations with crazy speed and accuracy, even suggesting it could be outperforming regular computers already.
And what's really caught everyone's attention is this idea of chemical accuracy. It's been like the holy grail for quantum chemists.
Okay, so for our listeners who aren't, quantum physicists, what does that even mean, chemical accuracy, and why is it so important?
So imagine you're trying to figure out how this really complex machine works, but you're only looking at the tiniest gears, the springs, all those little pieces, right? To get it right, you'd need insanely precise measurements and calculations.
You're talking like atomic level precision?
Exactly. Chemical accuracy is like that for molecules. It's about being so precise that we can predict how they'll act in the real world, down to their absolute most basic interactions.
So it's like having a super-powered microscope, but for the world of molecules.
That's a great way to put it. Being able to zoom in on those interactions in a way we never could before.
That makes sense, but why couldn't our regular supercomputers handle this? Why do we need quantum computers for this?
So traditional computers, even the really powerful ones, they hit a wall when it comes to the crazy complexity of how molecules actually behave, which is all down to quantum mechanics.
In quantum computers, they can handle that because they kind of speak the same language as those molecules.
Exactly. They operate on those same quantum principles, and that's where Qunova says they come in with their new algorithm, this HiVQE thing. They're claiming it can tap into the power of quantum computers to finally achieve that chemical accuracy everyone's been after.
I keep seeing them use this other phrase too, quantum advantage. Sounds impressive, but honestly, I'm not totally sure what it means.
Yeah, it's become a bit of a buzzword, but essentially quantum advantage is that point where a quantum computer can solve a problem way faster or just better than any regular computer could, even those massive supercomputers we have now.
And hitting that quantum advantage specifically for chemistry problems, that would be a game changer for all sorts of fields, right? Like medicine, material science.
Oh, absolutely. Imagine designing new drugs with incredible precision or creating materials with properties we've never seen before, all in a fraction of the time and for way less money. That's the promise of cracking this.
Okay, so what exactly is Qunova claiming they've done with this HiVQE algorithm? How close are they to actually delivering on all of this?
Well, they're not just claiming it works on one specific type of quantum computer, but on a bunch of different NISQ devices.
NISQ.
Sorry. Jargon alert. NISQ stands for Noisy Intermediate Scale Quantum Computers. It's a mouthful, I know. Basically, these are the kind of quantum computers we have right now. They're still being developed, hence the intermediate scale and noisy bit.
So they're making this work on the more experimental quantum computers. That's got to be impressive, right?
It suggests their algorithm isn't picky about the hardware, which is a good sign. They've even tested this HiVQE thing on a bunch of different molecules: lithium sulfide, hydrogen sulfide, water, and methane.
So they tested it on different molecules. Okay, that's interesting. What happened? What were the results?
Well, they actually did a live demo 3 days straight at this Quantum Korea 2024 event, running all these complex calculations right there for everyone to see.
Bold move, putting it all out there like that.
Right. And the thing is, this isn't some far-off thing. Qunova is saying they've got this running on an actual 20-qubit machine from this company, IQM Quantum Computers. They even did a test run on a 24-qubit IBM Quantum Eagle processor.
Okay, so this is real. But back to quantum advantage. Are they claiming they've actually hit it already with this HiVQE thing?
Well, they're saying that with a 40 to 60 qubit NISQ computer, they could potentially get there, yeah.
Hold on, NISQ, you're going to have to remind me.
Right, sorry, jargon again. NISQ, Noisy Intermediate Scale Quantum. It's basically what we've got right now in terms of quantum computers not perfect, hence noisy, and not huge, hence intermediate scale. What's interesting is that Qunova thinks they can hit quantum advantage with a pretty small number of these qubits.
So it's not about waiting for the perfect quantum computer to show up someday. They're saying they can do groundbreaking stuff with what we have now, or very soon at least. But what makes their algorithm, HiVQE, so special? What are they doing differently?
One big thing is how it simplifies the whole problem, makes it easier for the quantum computer to handle. Traditional methods, they often use something called polyword measurements, and those can introduce errors like static on a phone line.
So they got rid of the static.
Basically, they figured out a way to ditch those error-prone measurements, makes the whole calculation cleaner.
Streamline. I like it.
And here's the really smart part. They're using a hybrid approach. They don't try to make the quantum computer do everything, because remember, they're still kind of finicky. They use it for the toughest parts of the calculation, the stuff classical computers choke on, then hand the rest off to a normal computer.
Like a relay race. Quantum does the hard part, then passes the baton to classical to speed through to the end.
Exactly. It's about using the best tool for the job. And that's another reason everyone's so excited, because by doing this, Qunova thinks they can get these crazy good results with way fewer qubits than anyone thought possible.
Right, but 4060 qubits outperforming the best supercomputers on Earth. That just sounds almost too good to be true, doesn't it?
You're right to be a little skeptical. It's important to remember, Qunova's claims, while super exciting, they still need to be double-checked, replicated by other researchers, not just in a demo environment.
Healthy skepticism.
Exactly. Building these quantum computers, it's still incredibly difficult. The qubits themselves, they're so delicate, prone to errors. Imagine trying to balance a coin on its side during an earthquake.
Sounds stressful.
Kind of like that. Plus, there's the issue of scaling up. Even if they can do it with 4060 qubits, getting to hundreds, thousands, that's a whole other challenge.
So a lot that could still go wrong.
And even if everything goes perfectly, there's the question of how fast we can turn this into something with real-world use.
It feels like every few months it's breakthrough this, breakthrough that, then nothing much happens. So what are the experts saying about this? Are they buying it?
It's been interesting to see the reactions, for sure. Companies like IQM and AQT, they provided the hardware Qunova used, and they're definitely excited. These aren't just any tech companies either. They're leaders in this space.
So their endorsements actually mean something.
Yeah, I'd say so. In the press release, the head of strategic partnerships at IQM, he actually said, and I quote, "We are now entering the era when quantum computing can deliver real value for users in the form of new business applications." That's a pretty big statement.
Sounds like they're going all in on this, huh?
Yeah, and the CEO of AQT, he said something similar, emphasizing that what Qunova's made is hardware agnostic. Remember how we talked about it working on different quantum computers? That's what that means, like a universal remote control. But for quantum computers...
So that's just some niche thing. It could be used much more widely.
Exactly. And that's huge if this is really going to take off. But, and I know I sound like a broken record, even with all this excitement, we got to stay grounded. Qunova's claims need to be really put to the test by the scientific community.
Right, right. But just in case this is as revolutionary as it seems, what are the implications here? What could this mean for, everyone listening, for the world? So we've gone from what chemical accuracy even means to why hitting quantum advantage for this kind of thing would be massive. Right? Potentially changing how fast we find new medicines and way beyond that.
And we've dug into how Qunova is saying they've done just that, or are really close at least, by using this hybrid approach, quantum computers for the really heavy lifting, then classical computers to bring it all home.
It's a lot to wrap your head around. But before we let our listeners go, what's the big takeaway for you, the what if that this all sparks?
What I find most fascinating is that Qunova's work, whether it turns out exactly as they've described or not, it's making us rethink this whole idea of what computation even is.
Okay, I'm intrigued. Break that down for me.
We tend to think classical computing over here, quantum computing way over there, like they're two totally separate things.
Right, like it's got to be one or the other.
Exactly. But what if the real game changer is blending them together? This hybrid approach, using each type of computing for what it's best at, it could unlock stuff we haven't even dreamed of yet.
So it's not about picking a winner, quantum versus classical, but figuring out how they work together.
Exactly. And this isn't just about chemistry. Think about any field with problems that are just mind-bogglingly complex. Climate modeling, financial markets, even understanding the human brain. What if this hybrid thing is the key?
It's like we've been trying to solve these huge puzzles with only half the pieces, and Quunova's saying, hey, why not use all the pieces?
Perfect analogy. And that, to me, is incredibly exciting. It's not just about doing things a little better. It's about a totally new way of tackling problems, no matter what field you're in.
It's like opening a door to a whole new world. Well, that is all the time we have for today's deep dive into quantum chemistry and those groundbreaking claims from Qunova Computing. A huge thank you to you for walking us through all of this. It's a wild field to follow.
It was a pleasure to be here.
And to our listeners, whether you're deep in the weeds of quantum computing already or just starting to learn about it, we hope this has piqued your curiosity and given you plenty to think about. Until next time, keep exploring, keep asking those questions, and never lose that sense of wonder.